morning, everybody, or good night if you're still awake on the other side of the world. This is Jose, as they presented me, and I work for Nasapp. And today I'm going to talk about the insights from the CANMATA landfill study, where we are correlating data from other citizen reports and chemical sensors. So let me introduce a little bit what Nasapp is before starting. Nasapp is an IT platform that transforms odor perceptions into actionable data, combining citizen science, sensors, and weather information through AI to manage and prevent industrial odor. So basically what we do is we have an app where citizens can report their odor perceptions. We cross this information with weather information in order to see the weather conditions of the moment of the report and to do the backtracking of the odor. And we also get into this equation the sensor data, air quality sensors or e-noses, in order to give to our customers a whole ecosystem that helps them to analyze, manage, and prevent odor impact. The odor predictor here works through AI, with machine learning, and it gives you the chances of creating a new record in the next 4 hours. And it also gives you the impact zone that it would have if it is created. No? So with all of this, we help our customers to reduce their odor impact in their neighbors. So now moving on into the study, CANMATA is the second largest landfill in Europe. In Spain and Portugal. It also has a waste treatment plant in it, and it affects 7 different towns around it. It has a large problem with the neighbors, and we start working with them. I'm going too fast. Presentation is going slower than my voice. You can see the pictures here. Sorry about that. The affectation of the 7 towns, the neighbors, and now I'm in the same place. So basically what we are doing here, we are gathering in an action group, the citizens, the company that are running these facilities, and the government. In this study, we received 3,000 odor reports per year. You can see them in the map in a little. There's a big lag here. Sorry about that. So here you have the 3,000 reports. And what we do, if we had to look at all of these 3,000 reports one by one, it would be a nightmare, and we could not focus our attention to all of them. So what we do, basically, we classify these 1,000 reports in episodes. Basically, it's not the same 100 reports in one per day in 100 days than 100 reports in 1 hour. So what we do is we classify them in medium, severe, and episodes according to the number of reporters we have in the group and in slots of time. So by doing this, we pass from 3,000 reports to maybe 40 events in a year. You could see it in the next graph when it changes. I'm looking at YouTube, it doesn't change. Okay, here we go. So as we said, we pass from 3,000 reports to maybe 40 events. We have to check in 1 year in order to learn what happened in the biggest event. So we give them, you can see here, for example, if 12% of the reporters were doing a report, then we had a critical episode, and different protocols would be activated in order to analyze this study. In the next slide, once it changes, I'm sorry, I have to wait because this is a little bit slow. Well, in the next slide, here you have it. You can see the datasheet of every episode. You could see here the duration in the left side corner. You could see the duration of the episode. What was the participation of the people who are in this report? You could see the annoyance on the this episode, you could see geographically where all of these reports were reported, and you could see the backtracking. In this case, you could see that this is clearly caused by okay, so sorry, I was checking that Carlos Diaz was talking to me. So basically, you could see that the reports that the backtracking would affect is caused by this landfill. No? So all of this is used is based on the UNE standard 7727. We've had the honor to participate and to collaborate in writing the second chapter of the odor analysis. And in terms of chemical sensors, you can see that we had 5 sets of sensors of the company Veatch. We set these sensors in these different areas, and the way we treat these complaints and these readings is as the following. First, we check every time we have a complaint. We check if the air passed through the sensor. If it didn't, we disregard it. If we did, if the air passed through the sensor, then we see at what time did the sensor pass, the air pass through the sensor, and we draw a line here, a vertical line. Then you can see that which peaks we had at the time that the air was passing through the sensor. In this case, you could see clearly that there's a peak of hydrogen sulfide and sulfur dioxide. So by doing this, we are correlating the complaints with the sensor readings. So in this case, what we do? We analyze 4 compounds. One is hydrogen sulfide, ammonia, sulfur dioxide, and box. And we install the sensor in the waste treatment facility, in the leached basin, in the landfill front, in the unloading area, and in a point where we can control the flow towards Masquefa, which Masquefa is one of the 7 towns which has the biggest, or one of the biggest problems of odors in the city. So by doing this, we are studying 2 correlations. First, we are looking at when there is another report, then we are checking if we have a peak on our sensors. And we understand the peak as a 90th percentile number 90. And the second thing that we are looking is the other way around. So every time we have a compound peak, sensor peak, we check how many others reports did we have in the next hour within the 5-kilometer radius. So using the data from the first 3 months, today we will focus on the results from the leached basin. In the first case, you can see that 62% of the times we had another report, we had an hydrogen sulfide peak. 65% of the time we had an ammonia, we had a report, we had an ammonia peak. So 77% of the times we had another report, we had a sulfur dioxide peak, and 0% of the times we had another report, we had a box peak. In the second hypothesis, we can see the other, we are analyzing, remember, the opposite. So every time we had a peak, we are checking how many times we had a complaint within an hour and within a 5-kilometer radius. So 90% of the time we had a peak on hydrogen sulfide, we had a complaint. 97% we had a peak of ammonia, we had a complaint. And 100% of the times that we had a peak on sulfur dioxide, we had a complaint. And instead, in box, 9% of the times we had a peak, we had a complaint. So basically, there's no correlation here, as you can see in this graph. As you can see in the graph that for hydrogen sulfide, ammonia, and sulfur dioxide, there is a big correlation between peaks and reports. And you can see in the graph above the concentrations of these compounds. So, for example, you need very little amount of ammonia and sulfur dioxide in order to produce a report to make an annoyance to the citizens, and you need higher amounts of hydrogen sulfide in order to produce an annoyance to the citizen. So for the 3 main compounds, which are the hydrogen sulfide, the ammonia, and the sulfur dioxide, act as different indicators of odor. For example, sulfur dioxide is the most immediate indicator. When there is a peak, another is almost always detected at the same moment. In the case of ammonia, it's also strongly associated with odors, but only during the strongest episodes. And when it appears, there is usually a clear odor episode, although other compounds could be present at the same time. And for ammonia, ammonia behaves as a background indicator, more constant and diffuse. It does not produce very high peaks, but it constantly presents during sustained and widespread odor events. And in contrast, Box shows no significant correlation with other complaints, despite high concentration. This may indicate that the measure of organic compounds are not the main driver of detected odors, or that the concentration are below human perception threshold. Again, very important, this is the results that the data for the first months are showing to us. This may change with more data. We are planning to get more data, and we are looking forward to see the results and to see what's happening in the rest of the areas. And hopefully, we can show these results in future future meetings. So this is all for my side. This is my contact, and if anyone can write me, and if they wish, if they have any doubts or whatever. So this is all for me, and thank you everybody for listening, and I hope you have a nice event. Thank you.
Thank you very much, Jose.
Sorry, I thought there was delay, but then Carlos wrote me and told me that that was okay, so then I could move on and do it a little bit better. Sorry about that. I didn't know there was this 20-second delays between my presentation and YouTube.
Yeah, but I think you did great, and also thank you very much for your presentation. It was really very interesting, and you are perfectly on time also. So this leaves us some time for questions. I don't know if there are any questions in the chat. I can't see any. Marzio, can you confirm?
Yep. But I do in the case.
Okay.
Me too.
Please, Laura, please proceed.
No, I think it's very interesting work. So I really appreciate that. If I understand correctly, the sensors that you used are from bioair, right?
Correct.
Okay, that was my first curiosity. And my question is, what are the next steps? What are you planning? How are you planning to use now this information in the future to manage the odor pollution problem?
So first, our next step is to finish our study. This is only 3 months. We have a whole year in front of us to see if the data change these preliminary results. And with all of this, now we are training our odor predictor. So with this data, we are with these correlations, we are now training it. And once we have enough data, we can move to the second model of our second generation of this prediction algorithm in order to give better information. Also, we need to understand better what's happening there, because there's a huge problem, and with all of this information, we can understand better what's happening. And according to the results, we will do further tests, maybe air sampling. What we'll see depending on the results. Okay, but hopefully we will help them to understand better and to reduce the impact to the neighbors.
Thank you very much. Marzio, you had a question.
Yes, please, Jose. Only 2 curiosities. The first one is in the first part of the presentation, I've seen that essentially you have different threshold of alerts in which essentially you take the chance to alert the plant manager in order to say, hey, you have to know that there is some complaints, so please take care about your plant. My question is, have you had the chance to alert the plant manager, and due to this alert, has this person found a sort of extraordinary situation which theoretically may be responsible of this particular odor episode?
So basically, this is what we are doing, not only here, but in all of our customers. We have the example of Qatar, for example, which is an oil plant, industrial oil recycling plant. And they've been using Nasapp already for 20 years. It's actually one of the projects we were born for. And with this analysis and these alerts, they can start doing different protocols. They go through the factory to see what's happening, and constantly they find especially operating problems that they are doing or they are having in that moment, or that may affect in the future also. And by doing this trial and error and see what's happening, and all the time they are learning a lot of stuff and changing operations in order to reduce. And that's one of the keys functionalities of this system, or benefits of this system, so that they can do this small improvement little by little, like going to the gym, that you don't see the results one day, you have to go for months to see the results. And in this case, in Qatar case, we have been doing this for years, and we have had 97% of reduction of the odor reports in 20 years. So it helps them to improve.
No, surely. I see that probably within a petrochemical or oil refinery plant, this, let's say, can be done due to the complexity of the entire industrial process. My question was linked to the fact that in this case, you are monitoring a landfill, right? So in this case, let's say, it's rare to have a very particular operation which may be directly responsible. So my question was focused on, have you find any specific situation within the landfill which may be responsible of odor complaints?
So, yes, so there are plenty of complaints. I can remember now, for example, in the waste treatment plant, they saw that they were constantly operationally having a mistake on the doors, so they were leaving the doors open, and through these actions that they are going around the area, they can understand that they were having a problem on that, and they had to be more strict on that. That's a small problem that they could fix, but as you said, sometimes on landfills it's impossible to have to have a lot of impact. But at least you are having the data, and we're putting data onto the problem and see what's happening there. Plus, you can also check where the odor is coming to see where you have to focus your investment on other remediation methods.
Sorry, Marzio, to interrupt you, but we have a question in the chat, and just 2 minutes.
Okay.
Jose, which levels of H2S concentration do you measure? And also the question is, do you cross the H2S concentration with temperature and wind direction? So very short, we have only 1 minute left, but I hope you can still answer this question.
Well, the first part, I'm sorry, I cannot tell you. I don't really understand, or I don't know what does it mean. But for the second, of course, we are checking temperature, winds. You could see on one of the slides, you could see the temperature, the humidity, and the weather conditions constantly. So you are checking the reports with this, with the weather conditions. And from the wind directions, yes, we have the backtracking in order to see where the air mass was traveling from. And additionally, we give the wind, I don't know, the wind triangles, I don't know how they call it in English, La Rosa de Vientos. I don't know what's the name, but we give the information. Exactly. So we give this in order to do a second analysis to compare both results. So you can compare the backtracking and the wind direction in order to see if the backtracking was the correct, because sometimes when there is calm, backtrackings can become a little bit crazy, and then you have information of the wind to see that there was the wind was calm, and things can change, and the results can change according if you compare them to the backtracking. So we do that.
Thank you very much, Jose. Thank you very much again for your presentation. It has been great, and congratulations.
Thank you.